Hi, we are Group 1B. The product we are going to talk about in this video is Delft Instant Hand Sanitizer. This product consists of 11 ingredients. They are ethanol denaturation, water, which are main functional ingredients that kill most of germs, and solvents for other ingredients. PEG, PPG, 176 copolymer, and acrylate C1030 alcohol acrylate cross polymer. They are polymers that form gel and provide the ideal fluid behavior we want. The rest ingredients are conditioners, fragrance, and pigments that provide a smooth feeling, a pleasant lemon smell, and a clean, fresh color. When applying hand sanitizer on hands, its viscosity will decrease immediately. 3 small experiments were conducted. We put hand sanitizer onto a hot surface and added oil and salt to our hand sanitizer. The conclusion showed the viscosity is affected by salt on our hands. This is because when salt is added to this gel, the ionic charges are neutralized. The polymer chains collapse back to their initial coiled state and viscosity is lost. We compared our instant hand sanitizer with other 3 competitors' products and observed their viscosities by turning these bottles upstairs down and comparing the speed needed for these air bubbles to reach the top. Instant hand sanitizers from 4 different brands are arranged according to the order of their viscosities. We highlighted the ingredients that helps to form the gel. The Health and Beauty Instant Hand Sanitizer that has the lowest viscosity has no ingredients that can form gel. Delft and Aqueum have similar polymers, so it took similar time for air bubbles of the 2 products to reach the top. Palmolive has the highest viscosity because it used different polymers. The polymer used decided the viscosity of the products.
We performed a simple experiment to calculate the viscosity of the product. A spherical ball made up of marble was used in this experiment. Its diameter was measured and used to calculate the volume of the ball. Then the mass of the ball was measured and density of the sphere was calculated. In the next step, the product was filled in a graduated cylinder and the height of fluid was measured. The marble ball was dropped into this cylinder. Since the drop velocity of the marble ball in the fluid was very slow, so let's just skip through this part of the video and fast forward. The time taken by the ball to reach the ground state was noted down. This procedure was carried out 3 times to improve the precision of data. The average time was calculated and used to determine the velocity of the ball in the fluid. Finally, all the recorded data measurements were put in this formula to calculate the viscosity of the fluid, which came out to be 1.65 Pascal seconds or 1650 centipoise. Easy peasy.
We stored some hand sanitizer for 12 days. Apparently, the height reduced for 1.2 centimeters because of the volatilization of ethanol and water. So, if the product is stored for too long time, the antibacterial efficiency would decline. We tested the viscosity of stored and fresh hand sanitizer. The phenomena shows that the stored one has a higher viscosity. We did syringe test on hand sanitizer. In order to reduce the impact of static friction force within the needle, we pushed the piston with some 50 cents coins until it started moving. and move coins once at a time until the piston stops moving. We can calculate the differences of pushing force that move the piston, which is the force we can squeeze hand sanitizer out. It takes 4 to 5 50-cent coins to push air and 5 to 6 50-cent coins to push hand sanitizer. Each of the coin is 15.55 grams, so it takes about 0.152 Newton to squeeze hand sanitizer out. The force is too small, we can use that easily.